So in the last class, we have worked on creating the exceptions, handling those exceptions, what is the reason for getting the exceptions and others. And we understood like how to handle a single exception whenever it is occurring. But subsequently, when you are getting like more exceptions, how to handle it. So for doing that, we need to work on something else. So means here we handle like a single exception. When you get like multiple exceptions, then how to handle means we need to work with some kind of exception blocks. So here in Python, there is a one standard way. Standard way is that whenever you get like an exceptions, we need to adhere to certain amount of policies. Generally, in every language, it has its own structure. In Python, it has its own specific structure. What is the structure means? There are 4 blocks: try, except, else, and finally. Whatever the logic that you are thinking that it may result in a exception, you place it in the try block. It doesn't mean that every time you will get exception, right? When you are working on a code, password will not be expired every day. So it will be one random time. Or so for what are the types of exceptions you are occurring, you can handle it. If the user didn't enter some details properly, or if the issue with the password or something else, you will know because of some reason, something will come in the different way. So you can handle that exception. And if there is no exception, you can go with the else block and then the finally. So in general, there are 2 types of flows will happen. Sometimes when error occurs or when error doesn't occur. Whenever error is occurring, so first we will go to the try block. You got an error. So sorry, you didn't get any error. Then you will go to the else block. So when everything is good, you will write some logic. So then you can go to the finally. Similarly, when your error is occurring, when you did like a try block, then go to the except block to handle it. Then go to the finally. This may be new and different for you if you are coming from a different language, but it's very interesting to understand. So generally, everyone tells a simple logic. If you open an Android app or an iOS app, you are playing a game. Suddenly, you got like some big stack of error message saying that, so stack overflow or like plus minus some equations, something. Do you feel comfortable as an end user? Or if it just tells in a one line that check your internet connection. So obviously, as a user, you will be comfortable, right, to understand that. So how can the user get that issue? Because in the program, they have handled the exception whenever things are happening in that way, such that you will get that issue. In the same fashion, next time, when you are working, you should ensure the same thing. So here, if you observe, say I am doing like 10 by 0. If I execute it, what will happen? It will definitely throw an exception. Here and Python 03. You see what happened? The code was broken. Do you feel comfortable like this? Or if you have like a better way to handle it, so things would be much better, right? You remember, you handled this exception in a better way earlier itself. You wrote in try block, whatever you want, you wrote it. So you can just write like an except such that it will accept it. So now in this case, if you observe, it will execute and there is nothing wrong. It just executed it. So the reason being, it will execute and it will clear the screen. Clear and Python 03 so and so. You got nothing. But you know that whenever there is a block of code, there may an exception or there may not be an exception. What if instead of a 0, if I give like a 20, it will execute, but it is not an exception, right? So it is creating an exception. It is not creating an exception. But in both cases, we handle it. So, but what you handle, why you handle, there is a point, right? That you need to understand. So, in general, what will happen? Say you want to do some addition. You need to get the values in runtime and you need to perform something. Okay. Say you are taking like number 1 is equal to input of something. Enter a number. You are asking to enter the number, but user is entering something else. So you try to get the, so twice of that number. So 2.5 times that number. Okay, number 1. So if you see right now, if I execute, it is asking if I give like a 21, I get an error because we cannot multiply sequence of non-integers with a float. Who is a non-integer here? So because this, right? So how do you know that? So instead of blocking this code, can we write in this better way? Except, so if I do like an except, now if I do like in the previous case, it is asking, I give same 12 only, but I get nothing. So it is not printing, not getting anything. So this is not the point, right? You want to know what is the exception. You may think some n number of issues, but there can be n plus 1th issue. So whenever you want, so we can handle this like this, or the same thing we can have as an exception. In Python 2, instead of as, we can use under comma, sorry, but now win as. So what will be done with this as? It will create an object. So if I ask, hey, what is the example? Sorry, exception. So if I say 12, now did you see the same exception you got, but in a very clear way? Hey, can't multiply this. So the beauty of it is that if you want it to print like that, or you can do str of that object, or you can also do RAPR. So till now, I didn't tell what is the use of RAPR, but for the first time, you'll understand. When you do like a string, so by default and str both are same. Did you observe? What are you getting? I told for every exception, there are two parts. One, the type of exception, and two, the type of the message. So within the same exception, there can be multiple messages. If you observe str or gex, or you are getting the same thing. But when you do RAPR, it is like a raw representation. So that's the reason. So it raw representation means whatever the object is, as it is, it will replay. This object is of type error. Within that, this is the message. So that is the beauty of it. So then, sir, now if you go further, okay, I'm explaining the same example in much better way. So you can slowly come and you can understand. So whenever there is an exception, you understood RAPR is a good thing. So then, sir, what is the concept of this else then? Now you understood that, hey, whenever you got an exception, you need to print RAPR. Whenever there is no exception, you can print this value, right? So now you understood. If I give the same 12 again, I will get the same answer. Now I understood what is an issue. Because input takes everything like a string, that's the reason you are getting it. So now the point is, instead of accepting like this, you understood the problem that, hey, because it is not converting, you got this issue. So then what I will do? So instead of handling like this, I will comment and I will handle in a better way. What I will do? I will write like one more exception. Except, so what is this error that I'm getting? Type error as T error, something I wrote. So print of RAPR of T exception, you can write. And apart from that, so RAPR of TSH you can write. So then if you execute, did you see what happened? Well, what you got? You handle that exception, but still the code is broken. Did you observe? So where it is broken? Line number 59. So which is line number 59? Means when so try is working perfect, it is going to the accept. So where the issue is, did you observe? The issue is at this multiplication. Means this is also prone to some kind of issue. So then what I will do, instead of doing like this, did you observe that the error is coming here? If you observe, error is coming here. Means it doesn't mean that every time whatever logic you wrote in the try block will only give. So sometimes others also can give. In that case, what to do? Instead of placing that kind of troubled logic down, so we should write that here, result equal to so and so, and print the result. So this is the best way. Now, if I handle like this, now did you see what happened? I gave the same 12, I got the exception. Now, I can say like, when we need to give this generic exception or umbrella exception, and when we need to give the specific exception. So generally, whenever you identified some issue is coming in a particular way, you need to handle with that exception. So if you don't know what exception it is there, that we need to say like unhandled exception. Unhandled exception means though you handle all kinds of exception, you might get like a new one. That's what you want to see. Whereas here in this case, type error is why it is coming. Not every program type error comes for a particular reason. In this particular scenario, what we understood, type error when it will come, because it is of two different types. So what we understood as a human being, we understood that, hey, so ensure that number one is of integer type. So this is what a correct message, right? If it is like an integer type, then you won't get this issue at all. So if I execute this one, so what you are supposed to get? That message. But did you see what you are getting instead of that? Y. So now this concept of exceptions hierarchy come to picture. Exception hierarchy comes to picture. You remember on the other day, I told about this exceptional hierarchy. If you handle like a exception, which is like a umbrella exception, it can handle all these exceptions. If you handle like arithmetic errors, it can handle all these types of errors, right? And if you handle like a type error, did you see where is type error? It is way back down. Type error. So did you see type error is there, which can handle only the type. Whereas if you also give like an exception. So generally top to bottom, left to right execution. So Python will be a top to bottom, right to down execution. Then what will happen? First, did I encounter this umbrella exception? So it can handle all the things. Then why it will come to the next one? That's the reason, this linting is showing that code is unreachable, right? So now we understood the problem. So instead of that, if I write the same thing in a different way, see, I will write this one in the top and this one down. Did you see? You will have only one try block, one else block, and one finally block. But you can have any number of exception blocks. So when you are handling, if I give the same 12 again, did you see what it is saying? Hey, the issue, ensure that the number one is of type integer. So how beautiful it is. And in detail, if you further want, it is also telling. And this time you don't want the type error because you know exactly the type right here. So you just want to print the message itself. So you can do like str for it, or like you just print the message. So only when you don't have a handled exception, you want to know the type and the message. Got, sir. We understood what is the problem. Now, so to address this problem, what we are handling, we are placing this one. I'm writing in multiple things such that when you're practicing also, you can practice in this way. I understood that it should be like an integer or a float. So what I will do as a best thing, I will write like an integer. Fine. So I wrote like an integer. I wrote it. So 12 I gave, I got 30. So when there is no exception, the result is so and so. So we can write like result is like this. So now you understood. Whenever it is executing, whenever there is no issue, it will not go to the except block, it will come to the else block. If there is an issue, it will come there. Now I will do again further. If I say 12.3, now did you see what happened? Now this time another type of error came. What is this called as value error? Why this value error came? Because you are trying to give like a floating point value. So int has a problem, right? It cannot convert everything to a integer. So either we need to handle that in this way. So now like type error, we need to handle other error also. So and type error and these are like not related. We can handle separately. So hope you know, right? We should not write in the top, bottom. So value error, or like here also we can write fine, but not below the global exception. So as VEX, so print of, you know the issue, okay? Ensure that number one is integer type only, not floating point. If you think like value error can occur for different reasons, you can further write a specific thing. I understood that in this scenario, value error is occurring for this reason only. So that's why I wrote it. So if I say 12.3, did you see that? Ensure that you got like this. Okay, I give like a 0, it works. If I give like minus 34, it works. So I created a solution now. So what is the point of going for finally? So all done, say cleanup action. So basically see, now when I did like a finally, you will understand something interesting. If I execute, if I say 12, everything is good, you got the answer. If I say like next one, so Python 03 so and so. If I give 12.3, I got an exception, got it. Did you see that all done was executed any of these times? If I give something like some other data type, it failed. Ensure that so integer type only, not floating point value. So you didn't give a float, means the message should be more generic enough. So it can be any other data type, but you don't want, ensure it should be an integer only. You handle that garbage also. But did you see in all these options, so finally block is executing, all done cleanup actions, all done cleanup actions. So means in this particular case, so finally makes no sense. So whereas there are certain cases where finally will be making sense, means, so try block will execute in every time. In the try block, let's say you opened a file operation or a socket connection or a database connection. We should close that. For closing that, the finally block is there. To be frank, it makes no sense. Even if you write outside also, it will glow. But as a consistency, when you're writing, so it will be helpful to have all the things in one place. Okay. Now, this is what happens. I think I explained you the different cases where things are happening. Now, let me go for like one last use case. 04 exception handling .py. So now we understood the concept of exception blocks. And one more interesting point. So importance of this one, right? Let me take this example to help you understand. So I am taking two numbers and I want to add it. So then what will happen? Without the exceptions, I try to add. So if you see here, so it's a simple addition operation. You are taking two values and you want to do. So Python 04, Python 04. So you can see that addition is happening. But now What if I make one of them to a string? Will I get the answer? If I convert one of them to a string. So first time it will execute, but for the second one, it will throw an error. Because so we cannot add like a string and an integer. So that is the reason for that. We cannot do that. Now, sir, I want to make this thing in a runtime. So a similar logic, if I want to implement, so where the users need to pass the values in runtime, how do you achieve? So for that, I will take this value in input. So whatever we did, number one equal to, I will write. Similarly, this value input equal to number two equal to. So it's a very simple logic to answer. So I gave the values. So you gave like 100. So 20. You got it. So both are working. In fact, both strings also working. So if I give like, but this is not the correct. So, but what if you gave like, so 12.3, so 12.4, it is taking both of them, it is trying to add. So, so this is kind of a logical error. You didn't get an exception, but it is not correct, right? So this is kind of a logical error. So logical error, it's very simple for you to see, but it's difficult to debug sometimes. So what is the debugging? I will tell you afterwards. So now the point is, if I need to implement the same thing, so in a better way, so what we need to do? We need to write in the try block, which is the logic which may cause the issue. So these numbers or the addition. So numbers also can cause an issue when it reading, or like addition also can cause an issue when reading. So I wrote like a else block. Did you see? In this particular case, I wrote like a try block. So, and I wrote like an else block. So, but I didn't write the except block. Will it work? So it is saying like expected, except, and finally blocks. So I need either of that. So if you do like an except also fine, or finally also fine, but you cannot just write like try and else. So now if I do like a pass, I didn't write anything, fine. Did you see what happened? If I say 100, 200, it is working, something is happening. So now we need to handle this issue. So print exception. So how do you handle the unhandled exception as so and so? Generally, it's a best practice not to write like only one. So unhandled exception. EX. So we need to know the data type also so that we will understand. So it works perfectly. If you give 200s also, it works. Point so and so also, it works fine. But now we understood that, okay, this is not correct. We need to handle in a better way. So what I will do for this, I will convert to the integers. Int of number one and int of number two. So now what I will do? So I need to add it. If I execute, if I just don't give value, it will throw a value error. So, or like if I give something like a garbage, it throws a value error. Now I understood that it should be a value. So except value error. So as Vx. So you understood that this is a value error. So then what we'll say? Ensure that both inputs were integers only. So if I do like this, now it works. So if I say 100, 200, so now it works. But if I give like something else, point so and so, so it is saying like value error again, ensure that you are passing only integers. If I give any other garbage, it will fail. So it is fine. So now we understood this problem can be solved just with these two things. But if I go ahead with another thing, another problem. So where instead of addition, I want to do like a division. So division result is equal to, I want to get, so I want to do the division and I want to handle it. So addition, fine. So for division, it will be a bit more further complicated. I give like 100 or a 10, 20, it works. If I give like a 10, if I say like a 0, then it will throw in again error. Means we need to handle one more error called a zero division error. So let's say I will handle that. Accept zero division error as so and so. So print off. So you know that when a zero division error occurs, ensure that denominator is always non-zero, right? So this is what you understood. This is a problem. Now if I execute it, it works perfectly. If I say 100, 200, it works. If I say 100, if I say 0, it will throw an error. Ensure that denominator is always 1. Now, this is a good problem. Now we need to handle for like multiple exceptions. Multiple exceptions. .py. So the point is like, as the code is big enough, I'm going to the next one. That's it. So if I go for this multiple exceptions, multiple and multiple exceptions, you understood this problem, what we are facing. So we are having a division error, we are handling it. Now going for this hierarchy again. So now I'm coming to this zero division error. In terms of the hierarchy, did you observe that zero division error is under the arithmetic error and that is under this error? Now the point is, till now we know this global exception can handle everything. These three can handled by the arithmetic error, right? Now I want to check whether this can be done or not. So to ensure that, so I will add like one more exception. So same like this, I will copy, comment, and I will add it. So what I'll do, I'll take this arithmetic error and write it. Except arithmetic error as AEX. So print of arithmetic error either of. So what are this handling it? Floating point, either of floating point or overflow or zero division error occurred. Something you wrote a statement. Now I just want to check whether it is working as designed. So clear and Python 05. If I say 100, 200 works perfect. If I say 100 and a 0, did you see what happened? When I have only within this hierarchy, in that also we got like that, right? So if I do the same thing in a different order, you got it. Not just for the global error, for every hierarchy, it works in this way. If I just execute right now, if I say 100 and a 0, you will get to this zero division error only. Now hope you all understood. The standard errors will be the same only for everyone. Based on use case, we will understand which one to use at what time. Or, so now the same thing we understood. Whether it is like any of these errors, you want to handle in one better way. So for that, so we need to handle in a better way means multiple errors. So multiple errors means instead of handling those separately, I understood that any of these errors comes, ensure that inputs are valid. I want to write like that. So for that, what I'll do, I will write logic like this: zero division error or arithmetic error. So for any of these things, ensure that So denominator is floating point value, or you want to say like, so you want to write like this, okay? Ensure that denominator is so and so. For this, you want to write and you know about this new line operator, right? New line operator. Ensure that the denominator is always non-zero and ensure that both are so and so. If I wrote like this is how we handle like multiple errors in one place. So if I do like further and if I say point so and so, then also I will get error, but all errors are coming in the same place, right? This is called as like handling multiple errors. So the last point is about the exception groups and precedents and others. And one more thing is like, whenever you are having an issue, you want to raise an error. So that I will see afterwards.